Hello, welcome to another stream of learning Rust. Today we will be taking a look at functions. So let me just open up my terminal here. Okay. Just a minute. Yeah. So basically stream is fine. Okay. So we can we have seen like already seen what are functions like function main, which is the code which always get executed all the time, and we are already familiar with fn keyword which we use to declare a function. And for the function name we use lowercase letters and underscore, so that's called a snake case. Alright, and it doesn't matter where we are declaring function, like we can declare before main or after main. It doesn't matter. Only thing which matters is that the function should be declared if you are calling it. So for example here, if you run this code right here, you can see first it print hello world, then it called this another function, and inside the another function it's printing another function. So you can see how functions work here. And these functions can have parameters and we can pass arguments while calling them. So for example here you can see another function takes an parameter which is I32. An important point to note here is that the type of parameter must be specified, because Rust compiler needs to know what this type is. So you don't need to use it everywhere whenever you use that variable again. That's why while declaring a function you need to specify the types. So here in this example we are calling this another function which takes an 32-bit integer. Here we are passing 5, and inside the function it will print the value of the given argument. So if we just run it, you can see the value of x is 5. That's what we passed it here. So that's how the parameters work. And if you want to pass multiple parameters, you can just separate them by comma, like x which of type I32 and y of type I32. This type can be different if you want, but for now they are the same type. You can use different type, that doesn't really matter. And this is now another important concept, like function bodies contain statements and expression. So yeah. So what's the difference between statement and expression? Basically, whenever we use like semicolon or like inside a function which doesn't return anything, that's called a statement. Statement is something that some instruction that do not return any value. And on the other hand, expression like evaluate to something and returns a value. Like for example here, let y equal to 6 and semicolon. This evaluate to something but doesn't return anything. This function main is not returning anything. So we can say this whole thing is a statement. Like you can see a main function declaration containing one statement. So as we know, whenever we use statement, it doesn't return anything. So if we try to compile this program, error will come because we are using let y equal to 6, which is a statement which doesn't return anything. So there is no value to be binded by x here. So as you can see in compiler error, variable declaration using let, and there is no value to be assigned to x. So what happened here is that let y equal to x was a statement which doesn't return anything. So there isn't any value for x to bind to. Other programming language might return the value of assignment like in C or Ruby, but this doesn't take place in Rust. It's not the case in Rust. Then what are the expressions? You can see like 5 plus 6 is an expression which will evaluate to 11 and return 11. On also, if we just specify like 6, it's also an expression which evaluates to 6 and will return 6, like just the normal integer here. Or this this block we use for the scopes, or we can say like curly brackets, those are also expression. Let's take a look at it here. This 5 is an expression which will return 5, and that will get assigned to x. And here inside for y we are using this block, and you can see here we don't used any semicolon, right? We said x equal to let x equal to 3, and then just wrote x plus 1. So what it will do is it will evaluate x plus 1, which in our case will be 4, and then return 4. The main difference is expressions don't have semicolon at end. Here we can see it doesn't have any semicolon at end, so you can say it is an expression, so it will return it. If we run it, it should say the value of y is 4. Okay, some network issue. Yeah, the value of y is 4 because this block is an expression, so it is getting evaluated and it's returning its value. Same with the, suppose we have some function that returns something. So as you specified with the arguments, you have to specify the return type, like what type it is returning. In this example, the function 5 is returning an 32-bit integer, so we have to specify with this arrow which type it is returning. And notice here we are just using 5 inside function. So as we saw just now, 5 is going to be an expression, so it will return as it is. Here when we call 5, it will return an I32, which is 32-bit integer, and that is 5. And that's how this works. And if there are multiple things inside a function, it generally evaluates the last expression and returns it by default. And also you can use like this also for returning an expression. Here x plus 1 is an expression which gets returned. We are taking an argument and returning an I32. This expression is going to return. That's how. And also if you want to return instead, like in between the function, so without going to the end of function, we can use this return keyword to suppose there is a conditional check and we want to return, so we can use return keyword and specify a value to like explicitly return from that function immediately. But if you don't do that, the final expression at the end of function will be the thing which will determine what will the function return. So yeah, here is an example for that. If we have this function which returns x plus 1, this expression gets evaluated and will return this x plus 1 in our case, which will be 6. If we run it, we will see the 6 here. But here in the example below, we used semicolon here, so that means we are making it as a statement, and as we know, statement won't return anything, but we told it here that this function is going to return an I32. So this is not matching quite, right? We are saying it will return an I32, but here we are not returning anything. So a compiler will produce an error. It's saying we expected I32, but you return this empty tuple. So yeah, it's telling that it implicitly returned this because the function body has no tail or any return expression. And it's also giving us help, like consider removing this semicolon. So if we just remove the semicolon, this statement will become an expression which will return a value. So that's how the function and return works. And the empty tuple is by default what the function. If the function returns nothing, that means it's returning that empty tuple. Like you can say it's by default thing. And yep. And same as we saw in our coding examples also, what are comments? Like we can use this double slash for comments. So if I just go into my project which I have, and let me go into variables project for now, and let me show you what it's running or not. Please enter an array index. Yeah, it's working. So if I just try to add a comment in it here, so you can see here, if you want to add any comment, you can use double slash like this, like asking user for input, like that. It's not this comment, but you can use some better comments in the future. But yeah, you can use this double slash for using the comments, and you can actually use it like in many lines, like this is a comment. So yeah, this should be fine. And let me show you if it compiles. And yeah, you can see it compiles without any error. So comments just get ignored by the compiler. They are for the programmers to make code understandable. And you can use, like, there are multiple types of comment in Rust, like /star and document comment. We will see about them in later chapters. But for now, double slash for comments. And this is part of any programming language, which is control flow. Like, that's the core which drives the code. Without it, it won't be any use, right? So for like making decisions, first there is if expression. So let's just first create a project. I will name it branches. Okay, and so inside, let me try to use Sublime from it. And yeah, so this is our code here. And if we try to run it, cargo run, you can say it said condition was true, because what we are doing here, we are using if statement. So if our number was less than 5, in this case our number was 3, so this block gets evaluated, which is in front of if, which we call it as arm, like we called it in match arms. So same we call it here. And if this is not the case, we can also specify the else case, like if our condition is false, we can do this. So if I say instead 31 and then again run it, you can say it's saying condition was false. So that's how basic if else works. And if you have already programmed in any language, so this should be like very easy. That's just how if else statement work. And one thing to note here is that you can't like give anything to if statement. So if I remove this and make it as an integer, like number 3, if number 3, and if you might have seen in other programming languages, like if you just give a number which is not 0, it gets evaluated as true or boolean. But in Rust, you can see it shows an error saying expected boolean found integer. Rust doesn't convert them like that. You have to always give a boolean value in if statements. So, and if you want to just run the code, if it's not 0, you can just say like this and run it. So yeah, that's how the condition works. So we must give it like a boolean value. And there are nested if else also. So instead of if statement, after else we can use again if statement. So if you want to nest the code, and if we run it, 1 minute, I didn't save it. Yeah, you can see it is saying number is divisible by 3. So what's happening here, it goes in first if, it checks if number is divisible by 4. It isn't, so it goes in next else if statement. So it checks if number is divisible by 3, and indeed it was, because 6 is divisible by 3. So it prints this and skip whatever checks are next, because it doesn't do any checks if it already found a valid thing. That's why it didn't print like number is divisible by 2 and number is not divisible by 4, 3 or 2. And in future, instead of like this nested thing, if else, if else, if else, we can use match statements as we did in our coding game, guessing game. Match statement will make our code look much nicer. And also, if you want, just a second, and instead of, if you want to like assign a variable based on a condition, we can use this syntax. And we know this blocks is the block is an expression which will return a value, right? So, and we are returning a 5 here, which is also an expression. And so we are saying, so let me just show you by running. Save, run. Yeah, the value of number is 5 because condition was true. If I say it is false, then value of number is 6, because that's how we are using these expressions to return something. And one thing to note here is that this both should be of same type, because Rust compiler should know beforehand that what type the number going to be. We can't specify like this is going to be 6 and this will be 5, and Rust compiler don't want to. No, I don't want to purchase. If you run it, you can see it expected integer. And why it expected? Because in this if condition, in this block we have an integer, but in else block we have 6, which is not integer, which is a string, or str to be more precise. So yeah, Rust wouldn't be able to do this type of number, because this number is getting evaluated at runtime, and Rust compiler needs to know that type of the number at compile time. So that's why it's not going to work. We have to use the both numbers of same type. Yeah, and after this decision thing, like now we can make decisions, right, using if statements, if else or else if. But now what if you want to repeat the code again and again? Then we use loops. So there are 3 loops in Rust. First is a loop, which is a loop. Another is while and for loop. So first take a look at loop. What loop is basically like an infinite loop which keeps executing. So if I run this, yeah, see, unless I hit Ctrl C, it's getting executed. Like it failed my whole terminal here. Yeah. So, and if you want to break out of loop, you can use break keyword, like we did in our guessing game. When our guess was correct, we break out of loop using break statement. Sorry. And here is another example for it. Like here, we are using the loop, and inside loop, if we are checking if counter is equal to 10, we are breaking out of loop. And while breaking, we are also giving it an expression to return, which is counter into 2. This value is going to return. So if we run this code, you can see it returned result is 20, because this counter plus 1 will get executed until this condition is met. And once this condition is met, we are executing break, and while executing break, we are also giving a value to return. So yeah, That's what is happening here. We are returning 20, and this looks like very nested, like a loop, and inside of if condition to break outside of loop. Instead we can use like while loops for it. So you can write also same code inside a while loop. So instead of copying that code, let's try to write a while loop for it. So while our number, sorry, let me just check it. What was the condition? While counter, okay, while counter is not equal to 10, what we are going to do is like we are increasing counter by 1, and once it's done, we are saying our counter will let result equal to counter into 2, and if we run it, yeah, counter expected found integer. Okay, so we don't want to return it, just like it gets evaluated expression. We want a statement here, right? So we need a semicolon, and after 2 warnings, what are the warnings? Yeah, unused arithmetic operation. What we are doing? Oh, plus equal to, not we don't want to just add it, we want to assign it also. Yeah, and now it worked finally. So that's how we can use while loops. There are another uses like this. Okay, there are other uses like this. Like while number is not equal to 0, we are printing number, and once it's 0, we are printing lift off. Also, we can use while loop to print element of an array. So if we just copy it and paste it here, you can say 10, 20, 30, 40, 50, like it's going from index 0 to up to index 5. But when its index is 5, it just don't satisfy the condition and it breaks out printing this element. But what is the problem here, right? So if I add in next element and forget to update this, so we are not printing all the elements. And worst case is that if I remove an element, now it will iterate for time and code will panic. Let me run it. See, code panics here, index out of bound. So it's not quite safe to use like while loop, and they are not even that fast because compiler is adding this code to panic every time while it is iterating over it. So what we can do instead? Well, we can use for loop here. So instead we can use this. So what are we doing here, right? We are saying for each element in a dot iter. So iter is just iterable object which we will see later chapters, and also if you want you can see it here that yeah, it just iterable object which we can iterate over. So for every element in an array, we are just printing the value. So if I run it, yeah, you can see. And now even if I remove an element, see, it only printed 4 elements. So that's kind of nice. And also, as you saw it here, this function, we can also write it in for loop using this. So what it is doing is that 1 dot dot 4, as we saw like in the guessing game, this is the range. So 1 dot dot 4 actually means that it will be 1 2 3, not the 4, because it's like this is inclusive but this is not included, and dot rev is basically reversing it. So 1 2 3 will become 3 2 1, 3 2 and 1, and For that, for 3 it will print it, for 2 it will print it, for 1 it will print it, and then it will print lift off. So if I just run it, you can see 3 2 1 lift off. It's very much nice to use for loops for it. And that was the summary of it. It was all about the, we learned if expressions, loops, data types, functions, all that in last 2 videos. Now here are some challenges for us. Like convert temperature between Fahrenheit and Celsius, generate nth Fibonacci number, and print relics of this song. So we will do about it in next video, which will be tomorrow. We will solve these challenges, I think, and then I think we will stop here. If you have anything, you can ask in chat. If any. Yeah. So yeah, see you. Good night.